All right, guys, thanks for coming back and getting ready for another talk here. So you just saw me. I'm Jared Watts. I'm back again, and this talk here is going to be about day two. And so this is I think this is a great topic because what I've focused on a lot with a lot of the software that I write on like the Rook project is getting things up and running, deploying, configuring, bootstrapping, automating a lot of those things for day one of, okay, you've got a new shiny storage cluster. It's great. It's ready to work. And then what about day 2, 3, 4 through in, right? When real things start happening, users start coming on board, things fail, all that. So all these guys here have some industry experience, and I'm really excited to start asking them some questions as the moderator here. All right. So Niraj, can you tell us a little bit about where you work and what your environment is like?
Sure. So thanks for having me today. Really excited about this panel. I'm Niraj Tolia. I'm co-founder of Kasten. And we are a startup based on that focuses on data management on exactly the kind of topics we're going to be discussing today. Data management, including backup and recovery of your stateful applications, application migration, protection. So excited about sharing what we have learned together with our customers.
And Dmitry, can you tell us where you work and what your environment is like?
Sure. I came from academia, and I'm working for San Diego Supercomputer Center, University of California, San Diego. And we use Kubernetes to provide computing resources to scientists. So it's a little bit different to like just running your big application on it. We actually provide computing resources, and people come and they run their jobs, and we don't even know what they will run until they like start running. So it's a very challenging situation.
And Paul, go ahead and tell us about yourself too.
Sure. I'm an engineer at Comcast, and we have an on-prem Kubernetes deployment across multiple data centers. And what we do, we have a platform, we call it Data as a Service. And one of the biggest use cases of that platform is Elasticsearch. So we provide Elasticsearch as a service to other internal teams within Comcast.
All right, Paul. Since we're already focused on you, let's stay with you. So, Paul, tell me about what are some of the biggest challenges you see in day two operations, and then also some of the unexpected obstacles you can run into that you want to warn the audience about today.
I think all of us can worry about scaling. It's a different ballgame when you're dealing with hundreds of gigabytes to tens or hundreds of terabytes. And that's the problem that we have to deal with. But scaling and ability to manage the equipment that you have, whether it's VMs or on-prem equipment, is a big deal for that day two scenario, I think.
And those things that you've personally run into managing
Definitely.
Nice.
So whether it's if it's a VM, the stability of the host is a big factor with on-prem equipment. It's the stability of the equipment, whether it's disks failing, memory issues. I mean, all these things come up. From a VM level, you may not face it. It may be obfuscated to you, but you're still facing those issues, right?
All right, Dmitry, how about you? The same question of, what are some of the biggest obstacles you think you see for day two operations and unexpected things you run into?
So it's monitoring and again monitoring. And we started and we thought we have enough of it. And then we continue our operation and we decide we need much more monitoring. And first we need to report to NSF because we get money from NSF for our cluster. And we need to see what people are actually doing on the cluster, how they are using it. And we need like to know exactly where computing power is going, like how it's being utilized. Another thing is scientists are not very professional in computer science, and they just run some code the way they understand it. And we need to find the cases where they're not using hardware properly, where we can help them. And that again involves a bunch of monitoring and figuring out their workflow, how to help them, stuff like that. So yeah, we need to a full view of the system, and the more we go, the more we expand, the more we need to understand.
Yeah, so I think you kind of touched on something interesting there, is that the scientists and researchers that are using your platform, they don't use the system in a way that you expect them to use it.
Exactly. So they surprise us all the time. Like we think our system is great in some way, and then they come and they easily break it by the way that we never expected to.
And so when you have monitoring in place, at least you can see that happening.
Yes, without it, I'm blind completely. Like something is happening, I don't know what's happening. And now we have like, I don't know, 30 Grafana dashboards, and I go through them and I see something unexpected. Yeah, that helps a lot.
All right, Niraj, this one's for you. So let's talk about availability and durability, and what do those terms mean to you, and how do you keep your users' data safe?
Sure. I think we spend a lot of time thinking about this, and it's a very interesting problem because it's like what the keynote in the morning talked about. You really need to understand your application first and not trust anyone, and figure out those needs in the context of durability. That is, my data safe, it won't get destroyed, and availability. It's always available for my application. And this really involves solution at multiple levels, right? If someone tells you I can just solve it at one layer, it doesn't really work. But you need to combine things that happen at the storage layer. So whether you're using Snapshot for quick recovery or third-party software for backups to protect against maybe catastrophic infrastructure failure, you need that. But then on top of that, right, you need to understand your data service, whether it be a NoSQL system or relational database. How do you extract consistent data from that? How do you ensure that you have the right hooks to quiesce a database before you capture data? You want that in place, as well as replication at that layer. So, not just a storage replication, but data service replication, so you're always available. And finally, you pop back up one level to the application and understanding those needs. If you're a global organization, maybe you're doing stuff with your DNS or global load balancing, but then you need to understand the context of running across multiple data centers. What does it mean to sync data, handle network partitions, switch over, re-switch back over? And that suddenly starts getting complicated and honestly expensive in terms of what you need to invest to get that to really work. So whenever putting in solutions to handle that, understand what your application really needs and figure out at what layer, and generally you will involve more than one of those to figure out how to make your data resilient, durable, available.
Do you think that monitoring is something that can help out there as well to kind of keep the tabs on the health of the data, or that doesn't really flow in there well?
So when you're talking about things like availability, generally going to a dashboard to figure out what happened, you're already in some sense a little too late, right? I like what's happening with some of the operator stuff, whether you talk about Rook or something else that can automatically react to that. Monitoring will help to figure out, hey, what went wrong? So maybe you can dig into it, but you need more automated responses to failures happening versus saying, let's go figure it out.
And so, Dmitry, how about for the clusters and systems that you run? How do you make sure that data is always available for your researchers and scientists to use in weird ways?
Yeah, I think it's very important for the storage system that you choose, so that it provides you different options for data reliability. Because we have very different data sets and of different value. Some people come and they store like hundreds of terabytes or something like that data sets, but they don't expect them to be like super reliable 100% of the time with 3 copies, and we cannot store like 3 copies of a terabyte data set or like 100 terabyte data set. And then they if they store it somewhere else and they move it in, they make computation, move it out, we can just store it in not very reliable one. But if people come and they have smaller data set, but they really rely on like showing it at a conference, or they really depend on this data, we want to be sure that it's safe. And also we have our system data, like configuration, and also we have GitLab with all our source code and like images, stuff like that. So we want to be sure that this is 100% reliable. And for that data, we do backups to Google S3 from our system, additional to the capabilities that our storage provide. So we're kind of trying to balance between having a big volume and being reliable. And it's important that you have this choice.
So you touched on another interesting thing there with the nature of the data that's going through your cluster. So when you have your scientists or researchers, they're running these jobs, is that data inherently sort of just transient or temporary? Like it only needs to survive for the end of that job, or you don't have to archive all those hundreds and hundreds of terabytes for a long time?
As I said, it's different. If they store it somewhere else, they move it in, they make computation and they only care about the result. Then obviously we don't need to store the source data any longer than this job is done. Or sometimes they have some service running like a web portal that uses some data. Then it should be preserved for a longer period of time. And we work with them on case-to-case. So they just tell us what they want, and we say, okay, you better use S3 because you have huge collection of small files and you don't change them often. And somebody comes and, hey, I have like data which I need to read from several pods. And we say, okay, you need a shared file system. And so, yeah, this is, there is no solution for everyone. And our case is, I guess, unique. We run a global Kubernetes cluster, so we have nodes in Korea, in Hawaii, in Europe, and that's a part of same Kubernetes cluster, and our storage is spread across all those nodes. So instead of, there was a long problem of how you copy data to your processing, and so we don't copy it, we just mount it. Where your computation is running is just mounting from like, and data is everywhere pretty much.
So you don't have to move all the data around.
Yeah,
you just
exactly.
start, ad hoc, use what you need to, mounting it directly.
Yes, some users really need fast access. Then they copy it to local node when the computation is running, but then this data is purged when containers are gone. But yeah, this mounting paradigm is a big change because it was a big problem for all scientists for a long time, like how they copy the data. It's very unreliable to just copy it.
Yes, I'm sure the scientific community is thankful for that. Yeah. So Paul, how do you build confidence in your environment and make sure that if that things won't go wrong? Do you do stress testing and load testing ahead of time?
We do. We have separate clusters in VM environments as well as on-prem to be able to do the load testing. I think it's very important, not only from an application perspective to kind of stress test the application with the various subsystems like the disks or storage defined systems that we use. Software defined storage systems that we use. So to be able to see the performance of all the different layers, I think is very important. It gives us a bit of confidence every time we roll out a new application because we've at least went through a certain amount of tests that basically tell us that it can handle this particular sizing, can handle X amount of volume of data, X amount of volume of data for searching as well as for ingest. So it's important.
And so with those capacity, it seems like for that testing ahead of time, you get an idea of the capacity that it will be able to handle. Right. If that gets, if your users stretch it way past that capacity, what sort of situations do you run into and how do you deal with those?
So like Dmitry mentioned, Dima mentioned that you can't ever really expect your users to fit into a certain mold. They'll say that that they want X. What they really mean is they want Y or even Z, right? So you have to account for that a bit by adding in some headroom for all of your sizing. At least that's what we do. So we test for beyond whatever the use case may be. And that really helps. That really helps us to satisfy the needs of the users. But the ability to scale, essentially, we scale out horizontally. So if for our application for Elasticsearch, those of you that know Elasticsearch, you can simply add on more nodes with more storage, and the processing gets kind of spread out. The ingest increases fairly linearly, depending on various factors. But yeah.
And Niraj, do you have any thoughts also too about how you can be prepared ahead of time for noting, getting aware of where the potential failures might be in a system?
Yes, right. So again, multifaceted answer there, but really when we talk about testing, right, people frequently have staging environments, testing environments to bring stuff in. Something we started saying as people get more sophisticated with pipelines, more sophisticated with adoption of platforms such as Kubernetes, they're trying to figure out also not just how to test in staging, but also to bring real data in from production. And sometimes it involves sampling if your data in original data set is too large to be able to do it efficiently, or masking if your data is sensitive. But trying to bring data into your pipeline is, again, really great when you want to make sure your application code that works fine in staging will not fall over in production. So we're starting to see people that are somewhat at the more mature end of the scale starting to do that too.
And Dmitry, for your network too, I'm interested in how you can kind of prepare ahead of time and be aware of where the potential pitfalls are.
We found we cannot. Like, again,
Give some hope to the audience, please.
We have users, and they surprise us every day. We have test cluster, everything great works great there. We have bigger cluster, and just to test everything, we need another big cluster with the same set of users, and then we're prepared. So yeah, we just work with them, and we deal with consequences. Because really, scientists can surprise us. Yeah, right now there is a guy who brought our cluster to the, and we try not to limit it too much, because it's still we don't have any obligations to run it, and we kind of give freedom to people. So if somebody needs to run a big task, they can do it. Yeah, so we cannot test ahead of time. For example, we allow jobs running on the same nodes as storage, and if they can just take over all the resources, and then storage starts suffering. So recently we limited the requested resources for storage, but again, people can find the ways to damage it.
And that kind of speaks to something Quentin was talking about earlier too, of a hyper-converged architecture, when you have your compute and your storage co-located together in the same machines, and then when your compute runs amok and messes up your storage, it sounds like something you have to deal with.
Yeah, the biggest computation resources we provide now is GPUs, and we try to isolate GPU nodes from storage and CPUs, and that helps quite a bit. Because usually, most broken nodes that we need to restart are GPUs, and with huge computations on GPUs. But yeah, some people just run CPU tasks, and they can just request a bunch of memory. Memory leaks are a big problem. So now we mandate memory requests, and we limit it, so that people are aware that memory is not infinite, and they need to care about it. Another thing we are looking at now is using AI to predict this kind of situations, and to adjust the cluster properties, networking, storage, and stuff like that. We even look at chatbots to automate some tasks, and to look at monitoring. So this is something for the future, and we have some interesting projects with scientists regarding that.
Cool. And Paul, did you have something to add also about hyper-converged architecture?
I think Dent mentioned it. It's about setting your limits. And Kubernetes really offers the ability to kind of carve out those compute resources, so things don't step on each other. And we provide a high-performance environment for our users, and that means we really can't allow other users to step on each other for memory or even CPU resources.
Niraj, this is a question I am super curious about the answer, because I don't know the answer at all.
Yeah.
But so you have multiple roles in organizations, so developers, operations, admins, and then DevOps as well. And how do all those roles work together efficiently and play nice together for keeping things healthy?
Well, it's been very interesting getting a picture into some of this. Right? Sometimes people say the hardest thing about technology is people. This really does show up. And I am actually very, very hopeful for the cloud native ecosystem, because it is naturally causing some of these people barriers or silos to fall. So, in the olden days, by olden days, I mean 3 years ago, you would see, right, a storage team and a separate infrastructure team, a database engineering team. A lot of those things are coming together, and that's getting people to work better with each other. But we're still seeing issues when you talk about DevOps as an example. Large, mature organizations, when you have hundreds of applications running in cloud-native environments, you'll see operations team tend to, again, start getting specialized. And then where does responsibility lie? And we are seeing friction show up. So to give an example that's relevant to this context, when you go look at things like backups of your data, Dmitry talked about the example where users bring data back and forth between different examples. We see sometimes where developers have been tasked with saying, hey, back this data up. You need to make sure you hit all the compliance requirements for our company, but they sometimes have neither the skills nor the interest to go do so. And it's frustration. We've seen cases of people losing data. The GitLab data failure a couple of years ago is a public example of that. And really, it's about how do you empower people to work better together, whether giving developers the tools also to make this very easy for them, or on the flip side, actually sometimes maybe letting this pendulum swing back a little bit. When you say, hey, in a large, mature organization, you really want ops or the infrastructure team to manage data backups for the entire org, to make sure you're covered, to make sure your data is safe, it's durable.
And Dmitry, do you have any opinions on developers and operations and how they can coexist?
Yeah, we are building a nice community of everyone. So we started with Slack. We then shifted to Rocket Chat. So it's like Slack, but it's your private own universe. You can run it in Kubernetes. And so basically it's a chat with a bunch of channels, and you can have people. So we mandate that all our users come there and all admins, and so everyone involved in the project is in Rocket Chat. Everyone has it installed on their phone, and basically people are just talking. We saw people, users helping other users solve problems, and it's a nice community that's just helping each other.
Nice. So you're saying that is Slack already not cool?
Yeah.
Right. I cannot keep up with this. All right. Cool. So Paul, here's another question for you. So the hold on, let me remember what it was. Oh yeah, upgrades. So over time, hardware needs to be upgraded, software needs to be upgraded, and what steps do you take in your environment to make sure that's smoothly or deal with any issues that come up?
Yeah, I mentioned earlier we have a kind of an integration cluster that we do those upgrades in, and we test with real data. We actually kind of peel off some of the data streams that's coming in and pipe it into our test cluster. So we get to have the live data with the live dashboards that all the people use, all the nuances that the applications that needs to be tested. We do that. We follow a process to do an upgrade, see if it all works out. Hardware upgrades also. I mean, it's very difficult to do that, but with Kubernetes, it's actually a lot more simpler. Now you can move the pods around. The volumes of the PVCs that's mounted can be moved along with them, and as long as you have something that can handle a few seconds or a few minutes of outage, then you have a system that you can keep on upgrading while it's running.
And so that sounds like that gets into the whole pets versus cattle mentality of if you have a machine that's it's not special, it's not sacred, and you can kind of move it out, move it in easily, and upgrade it, then that sounds like that helps a lot.
It does.
Excellent. Niraj, another question for you. So let's talk about hybrid deployments. Like AWS Outpost is something that was announced recently. So tell us how that kind of shakes things up, or what people need to be aware of in these new types of deployments.
Sure. So when I look at, so people talk a lot about hybrid cloud, multi-cloud today. Looking at the enterprise section, we see definitely a lot more prevalence of hybrid cloud. Everyone still wants to talk about multi-cloud. You've seen Google do something with the cloud services platform, GKE on-prem, AWS's Outposts, things of that nature. And people are trying to figure out how do you really make it easy to have your applications be portable. Kubernetes is a big helper there. We are seeing that across the board where people are using Kubernetes as an abstraction layer. But again, for today, for this audience, data shows up often as a blocking factor as to how do you efficiently move data around. Some people approaching it from the storage layer. Maybe I replicate across different environments where I have the same storage system. Doesn't always work well when you're saying, let's replace AWS's EBS with something else, as an example. There's data gravity to figure out. But there are ways around this, right? People have worked on deduplication systems for a while. People have tried to figure out, hey, how do I stage in a different region for disaster recovery? So all of those are playing in. And we are seeing people trying to say, how do I make my data sets more portable? So I think this is something we'll see a lot of over the next couple of years. It's not going to be overnight. But we need to start thinking about, as a community, how do I make my entire application stack, not just the stateless components, but also the stateful components portable in these environments.
I think we have 1 or 2 minutes for any questions from the audience about running production clusters. And
I think it's a question to Paul. As we mentioned, this large-scale ELK environment that you're running. Can you talk a little bit about the scale, really, capacity, number of records you process a day, whatever?
Sure. We have a system that can handle approximately 50 terabytes of ingest per day. We currently the largest tenants of that system. It's in one. That's per data center. So it's probably doing a little over 1 terabyte per day in one specific ELK cluster. It's going to be ramping up to about 10 to 12 terabyte per day in that one particular tenant. And we run like a dozen right now, a dozen different tenants.
Just curious, with the, are you finding what sorts of operation help are you finding, like operators, like for each storage service, or anything like that? I mean, it seems like there's a trend for operators to take away some of the pain, but it also seems to be that there's a lot of misunderstanding about operators, for instance. And so, what are some of the building blocks that you guys are using to alleviate some of that pain, including going cross, as you mentioned, cross region from a locality? I guess you mentioned just mount points, but also, yeah, like either operators or like cross organization, cross DC types of things. Are there any like common things that you guys are finding?
Oh, so, I think I didn't quite get the question. Is it the operators you mean? Oh, oh, I see. Yeah, we're using, I don't know if I can say, but we're using Rook, which is operator on top of Ceph, and that simplifies deployment a lot. So basically, all operations are shipped to this layer. Myself, I wrote an operator to manage with users registration in the cluster, and so that's not for storage. Yeah, storage is mostly managed by this solution. But across the regions, we are now looking at multi-regional support also, because some users might want lower latency in other regions. For now, it's just one big pool that we throw our hardware to, and whatever it can give us is fine.
Alrighty, so that's all the time we have for this session. So let's thank Paul and Dmitry and Niraj.
Thanks, everyone.